All right, so taking a look at the relationships in special right triangles is section 8.3. We're going to take a look at what are 45, 45, 90 triangles and what are 30, 60, 90 triangles. So starting out with a 45, 45, 90 triangle, what that means is that you have a right triangle that has two 45-degree angles as well as a 90-degree angle. Now, if I have a right triangle right here and I have the two angles are both 45 degrees. Well, from our isosceles triangle theorem, that's going to tell us that we have an isosceles triangle, that these two legs of our right triangle have to be congruent to each other. So if those two sides are congruent to each other, let's take a look at what's going to happen with the relationship with your hypotenuse that's here. So let's let each side here be x. If the Pythagorean theorem says that a squared plus b squared equals c squared, then x squared plus x squared equals c squared. X squared plus x squared gives us 2x squared equals c squared. And before I would take the square root, I would need to go ahead, since I'm solving for c, I can go ahead and take the square root of both sides. And what this is going to end up giving us, let me just find it here. The square root of 2, we don't know what that is, but we do know the square root of x squared is x. So I get x square roots of 2 is equal to c. Your hypotenuse here ends up giving us x square roots of 2. Now, let me just go and take a look at a triangle here. And let's say that since the sides have to be the same, let's work with an isosceles triangle here of length 5 and length 5, and we're trying to see what the value of c is. Well, 5 squared plus 5 squared is equal to c squared. 25 plus 25 is going to give us 50. And so 50 equals c squared. If we go ahead and take the square root of this, c is going to be equal to the square root of 25 times the square root of 2, and we get 5 square roots of 2. Now, the reason that I'm showing you this is because this follows our pattern of x, x, and x square roots of 2. So you'll notice here that both of our legs are the same, and then if I look at the hypotenuse here, which is x squared roots of 2, notice that your two side lengths are 5. If we were to do the same problem here, and let's say we chose a side length of 6. So now I'm going to choose 6. So that means that we would have 6 squared plus 6 squared is equal to c squared. 36 plus 36 is equal to c squared. So that would be 100 and, I'm sorry, not 100, 72. 72 is equal to c squared. Square root of both sides, and you end up simplifying this to the square root of 30, here, sorry. So your value of c is equal to the square root of 72, which you could do as a square root of 36 times the square root of 2, and then we get 6 square roots of 2. So hopefully you are identifying now that there's a pattern that's happening with these 45, 45, 90 triangles. The first thing is that the legs are always congruent to each other, so that's why I'm putting the value for n for both of these. The next part of this here is that your hypotenuse is always the length of one of those legs times the square root of 2 then. And this is just because when you work out your Pythagorean theorem, you saw that as I simplified all those values, we ended up with that value of n square roots of 2. Now at the top of your page, just kind of like in the last video, just for me to kind of realize that if you are listening to this and if you are taking your notes, if you would go ahead and write the word tiger up at the top of your note sheet or at the top of your foldable, whatever it may be, just write the word tiger. Don't tell anyone that you're doing this, just write out tiger. That's just a way for me to know that yes, you were watching the video and yes, you were listening to it. All right, so real quick, here's another example of 45, 45, 90 triangle. And now what we can do, knowing the information that we have, if I just give you one side, so say that this side right here is 7, we could easily find the sides of x and y. Because the two legs have to be the same, that means that x would have to be 7. And your hypotenuse is always going to be the leg times the square root of 2. So x would be 7, y would equal 7 square roots of 2. If I told you that your hypotenuse was, say, 11 square roots of 2. Well, if your hypotenuse is 11 square roots of 2, then that means that your two sides would both have to be 11. Now, what happens if I were to say that your hypotenuse was, let's say, 12, and you had to find your two sides? This is a little bit more challenging because when we look at the 12 here, it's not in the form of being as a square root of 2. And we know that the two legs here are going to be that end part. Well, what I've done here now is I've just created an equation that now you could solve for the value of n. So if 12 is equal to n square roots of 2, we could divide both equations by the square root of 2. So n equals 12 divided by the square root of 2. Now we talked about how we rationalize our denominators, how you divide by square roots. We want to get rid of that. So I'm going to multiply numerator and denominator by the square root of 2. That gives us 12 square roots of 2 over the square root of 4, which is 2. So 12 square roots of 2 over 2 would simplify to 6 square roots of 2. And that would be our value for n. So our two legs here would be 6 square roots of 2 for both of them. So again, I just created an equation for this. Let's do one more just like that real quick. Say I had a hypotenuse that's going to be 15. And we're trying to figure out what the two legs are. Well, 15, that's your hypotenuse, so that has to equal n squared roots of 2. So really you're trying to figure out what number are you multiplying by the square root of 2 to get 15. So that means 15 equals n squared roots of 2. We're going to divide by the square root of 2. N equals 15 over the square root of 2. Rationalize your denominator. Multiply numerator and denominator by the square root of 2. So we get 15 square roots of 2 over the square root of 4, which is 2. And so if you want to, you could write this as 7.5 square roots of 2, or you can leave it as 15 square roots of 2 over 2. And then those right there would be your two sides of your right triangle. All right, moving on to a 30, 60, 90 triangle. This one right here, what we're going to talk about is the relationship that's happening about the three sides. First of all, from the angles that we are given, there's going to be a shortest leg, there's going to be a longest leg, and then there's your hypotenuse. Now your hypotenuse will always be the longest side, but as far as the other two legs go, your shortest leg is always going to be opposite of your 30 degrees. And then your longest leg is going to be opposite of your 60 degrees. So those two things we need to understand. The reason why we need to understand that is because everything is going to revolve around your shortest leg. So as far as the rules that go with the 30, 60, 90 triangle, everything goes with your shortest leg. So that's where I'm going to go ahead and I'm going to put my n value here. All sides have a relationship to the shortest leg, so I'm referring to that to n. The hypotenuse is always always 2 times the shortest leg. So your hypotenuse is going to be double whatever that shortest leg is. Your longest leg is going to be your shortest leg times the square root of 3. Now, if I went through and I solved this here, n squared plus n square roots of 3, and I square that, trying to see, does this equal 2n squared? It will. Using your Pythagorean theorem. So n squared When I square this here, this is going to end up giving me 3n squared equals 4n squared. Well then, n squared plus 3n squared gives me 4n squared. So here you end up with the fact that those three sides do satisfy the Pythagorean theorem. So with an example, say I give you a 30, 60, 90 triangle here where your hypotenuse is 14. Well, that means that it's 2 times your shortest leg. So if 14 is equal to 2n, you could go ahead and divide both sides by 2, and n is equal to 7. So your shortest leg here would have to be 7. Your longest leg is going to be n square roots of 3, so therefore it would be 7 square roots of 3 for your longest leg. I'm going to go ahead and move this 8 over here. So if your shortest leg was 8, that's your value of n. You can double that to get your hypotenuse. So your hypotenuse here would have to be 16. And then your longest leg is going to be the shortest leg times the square root of 3. So very easy to do if you are given the shortest leg, or also if you're given the hypotenuse. Where you have to be careful is if you were given a value like this 8. If I was to put this down here at the longest leg here, saying that this is 8, and we're trying to figure out what the shortest leg and the hypotenuse is, well, I need to know what n is to be able to do that. Since 8 is equal to n square roots of 3, use this to go ahead and solve for what n is. We can divide by the square root of 3. So n is equal to 8 divided by the square root of 3. Rationalize your denominator. Multiply the numerator and denominator by the square root of 3. That gives us 8 square roots of 3 over 3. So that's what your n value is. So over here, our shortest leg is 8 square roots of 3 over 3. Doubling that, if I take 2 times that, I would get 16 square roots of 3 over 3. We would just double that. So let me go ahead and do another example like that. Now, at the top of your paper, if you would please write down the word pride. So just to kind of show that you watched this video, if you would go ahead and write down the word pride somewhere at the top of your page, that would be great. Thanks. All right, so now 30, 60, 90, let's go with a side length here of 12. You're trying to find now your shortest leg as well as your hypotenuse. So your longest leg is 12, so that equals n square roots of 3. So to find your other equations, go ahead and, sorry, this sometimes, I just gotta get it cut. So to find our shortest leg, I'm going to set up the equation. So 12 equals n times the square root of 3. Divide both sides of our equation by the square root of 3. N equals 12 divided by the square root of 3. Rationalize our denominator. And 12 times the square root of 3 over 3, which can simplify to 4 square roots of 3. So our shortest leg here is going to be 4 square roots of 3. If we double that, we would get 8 square roots of 3. All right, so there we are. You've got your examples of 30, 60, 90 triangles, and we'll see how we can apply this to some other stuff when you come to class.